Good morning to one and all. So, in the last session, we have discussed what is meant by complements, what are the different types of complements, and what is the significance of complements. So, now in this session, let us start the application of a complement in digital systems. So, in case of complements, among r's and r minus 1's complement will be generally used 1's and 2's complement. So, in case of 1's and 2's complement, now let us see how to perform different arithmetic operations. That is, the importance of the complement itself is performing subtraction operation by using addition process. So, here now in this session I am going to discuss about how to perform subtraction using complements. So here I am doing an arithmetic operation of subtraction using complements. So here I am doing a subtraction operation indirectly as an addition operation by either 1's complement or a 2's complement. Whatever may be the complement, whether it may be a 1's complement or a 2's complement, we need to follow some sort of steps. So the first step is write the given number in binary. So if the given number is not in a binary, if it is in the decimal, first convert the decimal number into a binary. The next is, here we are going to perform a subtraction operation. So let me take, I am performing A minus B. So here A is one number, B is other number. I need to perform a subtraction operation of A minus B. So here A is called as minus and B is called as subtrahend. So whichever the number which is having a negative sign, it is called as a subtrahend. So in this case, what I am doing over here is perform either 1's complement or 2's complement for subtrahend. So here the subtrahend is nothing but B. So for this B number, we need to perform, if we are doing the subtraction using 1's, perform 1's complement. If we are doing the subtraction for 2's, you need to perform 2's complement for the B. And the third step is add complement of subtrahend to minor. So here that is 1's or 2's complement of B plus A. This is the step 3. And step 4 is, whenever you are performing addition of B plus A, that is 1's or 2's complement of B plus A, if we are getting a carry, discard that carry, that is discard is nothing but you need to neglect. Discard that carry of it is 2's complement. If we are getting a carry, discard that carry in 2's complement. If we are performing by using 1's complement, if we are getting a carry, in case of 1's complement, add that carry to LSB. The only difference between 1's and 2's number while performing a subtraction operation. So let us do the subtraction operation using either a 1's complement or a 2's complement. Now let me take a simple example of 7 minus 3. That is 7 is decimal number, 3 is also a decimal number, but I want to perform using 1's complement. So as we know that the 7 equivalent in binary is 111 minus 3 equivalent is 111. The most important point which you need to do over here is first convert the given number into a binary equivalent. After converting, we need to check how many number of digits are present in case of subtrahend as well as minuend. So in this example, the first number is having 3 number of digits and the second is having only 2 number of digits. So we need to add othermost step, which is nothing but we need to equate the number of bits or number of digits. So here equating the number of digits is nothing but adding or appending a 0 to that number is nothing but called as equating. So I can write 111 base 2 minus 011 base 2. So here the first number is having 3 digits, the second number is also having 3 digits. So this is all about step 1, that is write the given number in the binary form. I have converted 7 into a binary as well as 3 into a binary. As there are number of digits are not equal, I am equating both the number of digits. And the second one is, as I am saying that I want to perform this subtraction using 1's complement. So among these two, the second number is a negative number. So this is step 1. So the step 2 is we need to perform 1's complement for a negative number. Here negative number is 011. So 1's complement for 011 is 1's complement is nothing but replacing 0 with 1 and 1 with 0. So here it is 0 is there, it is 1. Here it is 1 is there, 0, 0. Base is 2. So the 1's complement for 011 is 100. And the next step 3 is we need to add 1's complement of a negative number followed by a positive number. So 1's complement of 011 is 100 plus a positive number which is nothing but 111. 0 plus 1, 1, 0 plus 1, 1, 1 plus 1. We are not performing here a decimal operation, we are performing here a binary operation. So 1 plus 1 in decimal is 2. The 2 equivalent in binary is 0 with the carry 1. So here 1 plus 1 is 0 with the carry 1. So here if you observe here, if we are getting a carry, so the original number of bits are 3, here also 3, but the result which we are having is 4. So here 4 itself indicates this is an excess bit other than having this original bits. This bit is called as a carry bit. So in this, whenever we are performing a 1's complement, what we have discussed, if we are getting a carry, we need to add that carry to the LSB. So here the last step is the result is 011. This carry should be added towards an LSB. So here this is an LSB. 1 plus 1 0 with the carry 1. 1 plus 1 0 with the carry 1. So the result is 100. If we convert this 100 in terms of the decimal, this is 2 power 0, 2 power 1, 2 square. So it is nothing but equivalent to 4 in case of a decimal. So in general, 7 minus 3 is also 4. Here in complete this process, even though we are performing a subtraction operation, we didn't do the subtraction operation, but we did the subtraction operation. So here the given number is 7 minus 3 using 2's complement. So here 7 equivalent in binary is 111, which is base 2, and 3 equivalent is 11. As we have discussed, we need to equate the number of digits or bits. So I need to write down 0, 11, base is 2. But in the previous example, we have done the same thing by using a 1's complement. Now we need to do by using it as 2's complement. So in case of a 2's complement, the only change over here is instead of performing a 1's complement to the negative number, we need to perform a 2's complement. So the step 2 is, here the negative number is 0, 11. So for 0, 11, 2's complement for 0, 11 is, I am here performing a second method, that is wherever I am getting a first one, till that first one I am writing as it is, and the remaining bits I am performing it as 1's complement. So in case of a 0, 11, I am getting the first one here, so I will be writing the LSB bit as it is, but the remaining two bits I am replacing 0 with 1 and 1 with 0. So here I will be getting 1, 0, 1 base 2. So here 1, 0, 1 is a 2's complement for 0, 11. And step 3 is, we need to add 2's complement of a negative number with the positive number. So the 2's complement of a negative number is 101 and the positive number is 111. So if we are performing an addition, 1 plus 1, 0 with carry 1, here also 0 with carry 1, here we are getting 3 ones. In decimal, 1 plus 1 is 3, but in case of binary, that is 3, convert this into binary, so the equivalent is 1 followed by 1, that is sum is 1, carry is also 1. So here in this case, this is a carry bit. So if you remember the step 4, we have discussed in steps in such a way that whenever you are performing a 2's complement, if you are getting a carry in case of a 2's complement, you need to discard. This is carry bit is discarded, that is carry bit should be neglected. So the final result is 100, which is base 2, which is equivalent to 4. So if you observe this, that is by using 1's and 2's complement, whatever may be the method, whether we are performing a 1's complement method or a 2's complement method, the final result is same, which is equivalent to plus 4 in both the complements. But we are preferring 2's complement rather than using 1's complement, because whenever we are writing the equivalent for plus 0 and minus 0, we will be getting only one notation, which is equivalent to all zeros in case of only 2's complement but not in 1's complement. And repeat that here 0 itself indicates only 3 zeros. As it is plus, I am representing the sign bit as 0. As it is a negative number, I am representing sign bit as 1 and all the remaining bits are 0. So if we perform 2's complement, that is 1's complement as well as 2's complement, basically this 1's complement and 2's complement and sign magnitude representation is used in order to represent only the negative numbers but not the positive numbers, because defaultly the positive numbers will be having the sign bit as 0. But whenever we are coming across a negative number, only for the negative numbers we are having a sign bit as 1. That is the reason we can represent negative numbers in 3 different notations. One is sign magnitude, second is 1's complement, and the third is 2's complement. So here in this case the 1's complement is nothing but just replacing 1 with 0 and 0 with 1. So this equivalent which I will be getting is 0, 111. And for negative number, that is for negative number, if you are performing this is 1's. If you are performing a 2's complement wherever we are having, that is first MSB bit. So 1's complement plus 1. So 1 plus 1 0 with carry 1, 1 plus 1 0 with carry 1, 1 plus 1 0 with carry 1. So here whenever we are performing in this way, we are getting that is 1 followed by 000, in which these 3 bits represents the magnitude. So here whether we are using a plus 0 or minus 0, the magnitude of these numbers are same only in case of 2's. But whereas in case of 1's complement, we are not getting all zeros. That is the reason 2's complement is mostly preferred rather than using a 1's complement. This is all about how to perform a subtraction operation using 1's complement as well as 2's complement. Now let us see another more example in such a way that in this case I have taken both, that is either it may be a 1's complement or a 2's complement. I have subtracted a number, that is highest number minus lowest number. But let me take an example in such a way that lowest minus highest, that is a reverse process, which is nothing but 3 minus 7 using 2's complement. So here 3 equivalent is 1 1, 7 equivalent is 111. We need to equate both the number of digits. So here 0 1 1 minus 111 base 2. This is step 1. Step 2, perform 2's complement for the negative number. So the 2's complement for the negative number is 2's complement of 111 is, write down the first bit as it is and the remaining as 1's complement. Step 3 is add 2's complement of a negative number followed by a positive number. So the 2's complement of a negative number is operations.